Hello everyone, this is the presentation video for EE123 final project. We will introduce two main parts of our works. Let's start with the transmission part.
So for the transmission side, we just built off of the Lab 5 code. After we compress the videos, we construct the packets using the compressed data, and then we perform AFSK 2400 on the packets, and then we transmit them to one of the FM radios, and then we receive with another FM radio, filter and demodulate the AFSK 2400, and then we find the packets in the recorded sequence and extract the data to be reconstructed.
And then, so the main problems we wanted to tackle with regards to transmission, where we wanted to increase the amount of data we could send, so increasing the data transfer rate. We also wanted to limit the amount of error, so that deals with reducing the bit error rate. And so to do the first one, we reduced the overhead in the packets. And so we only kept 5 flags, and we only kept the info portion of the packet, and then we also increased the baud rate from 1200 to 2400. And then to reduce the bit error rate, we increased the spacing between the mark and space frequency, and we saw that that gave us good enough results. And we were able to achieve a significant improvement from the original Lab 5 code. Once we've received all the data, we just stop recording, and then we take items out of the queue, and then we decode and reconstruct the image. And then here, we unzip the file that we've received, and we decompress it.
And then it's the compression part. We've written the strong and adaptive framework for our project so that we can add new compression method whenever the hell we want to. First of all, downsample is pretty easy and straightforward. It's just the decimation in space, but it guaranteed the compression effect we want. Right now we have stable version of downsample and PCA compression. This is what a downsampled Simpson looks like. And this is a Simpson with only principal components, which is still yellow. And we have an unstable version of JPEG. I've spent about 10 hours. I mean, it's nearly a day to implement the JPEG. However, well, it doesn't work. So after 4 hours of coding I start to run the code.
Yeah, boy.
Screw it. Anyway, we still have an awesome PCA. Let's see how we implement that.
The result of downsampled videos will be input to PCA for further compression, and because PCA relies on the correlation between variables, which is different rows, in our case, I would partition the input video by their spatial locations into rows and columns, so each subsection would be more correlated, and each color channel in a frame will be separated by row. So all these frames with their color channels will be stacked together and input into PCA, and only the principal components that capture a certain percentages of total variance will be retained. And this example shows retaining only the principal components that capture at least 5% of total variance and resulting in a 7:1 compression ratio.